Welcome back everyone to our continued discussion on the Matplotlib figure object. Now that we understand more or less visually what's happening behind the scenes, where we have a background canvas, figure, then we add a set of axes, and then we plot on that set of axes, let's go ahead and actually implement this with Python code. I'm going to jump to a Jupyter Notebook. Alright, here I am at the notebook. I've already imported NumPy as NP and Matplotlib.pyplot as PLT. Next, we're going to need some data to actually plot out. So what I'm going to do is I'm going to create two sets of arrays. The first set I'm going to call A, and it's going to be linearly spaced points. We'll go from 0 to 10, and then let's go ahead and have 11 linearly spaced points. And then B is just going to be the array A to the power of 4. So if I see A here, I have 0 to 10, and then B is essentially each of those numbers to the power of 4. So you can see we start getting really large numbers as we get higher and higher here. All right, the next one is going to be a little simpler. I'm just going to say x is equal to np arrange 0 to 10, and then y is equal to 2 times x. So x, 0, 1, 2, 3, all the way to 9, and then y is 0, 2, 4, 6, etc. So as a quick reminder, you can use np linspace to get linearly spaced points. So here we're asking for 11 linearly spaced points between 0 and 10. You could always expand on this number to get more detailed points. And then arrange simply gives you the integers spaced out by default by 1. So now that I have these two arrays, let's go ahead and actually see a lot of the topics we just learned about in the previous lecture. The first one is to create that blank canvas figure object. So you can just say in one cell, fig, plt figure, open and close parentheses, and when you run this, you should see a report back to you that actually says, hey, we created a blank figure, which is by default size of these pixels, and then it has 0 axes on it. So this is a blank canvas, and recall, as I mentioned, we don't actually get to see it, but it will report back the details if you do not draw a set of axes on it. So next thing we can do is explore the different properties we have here. The main properties that I like to focus on when creating a figure object are the figure size and then the DPI, essentially the fidelity of dots per square inch. So keep that in mind that we will be editing these later on. Right now we'll just keep them at the default though, which is the nones. And what we're going to do next is in the very same cell, we're going to add a set of axes to that figure. So I'll say axes is equal to, we grab that fig variable we just created and then say add axes. And then if I want something to go at the bottom left of that canvas, I'll say 0, 0. And then 1, 1 is the width and height, as we already discussed, of the entire canvas. So now I have this blank figure canvas, and I'm going to add a set of axes, which is essentially the exact same size as the canvas in the same location as well. So now when I run this, I get to see that set of axes. All right, then the last step is to actually plot on that set of axes. So if you say axes dot, and then we're going to say plot, you can pass in either XY or AB. So we can go ahead and run that. And here we can see that we've plotted. And notice now it's actually telling you we just plotted this line to the object at this location in memory. And again, if you want to get rid of that message on Jupyter Notebook, you can just simply say semicolon and it will get rid of it. Or alternatively, you can say plt.show. And as I've mentioned before, if you are running this as a .py script, you will need to, by default, have to say plt.show in order to actually see the window that opens up this figure. So you run that, and now we can see the figure itself. Okay, so another quick note for Jupyter Notebook users, all these commands should be going inside the same cell. But we essentially just completed the main steps, which was create a figure, add a set of axes to that figure, determine the location and size of that set of axes, and then go ahead and plot on that set of axes, and then show the figure. So then we could switch it out for, instead of x by y, say instead plot a and b. We run that, and notice we get this exponential curve, since the relationship here is the b is equal to a to the power of 4. All right, now I've zoomed out a bit so we can see the effect of adding multiple set of axes to the same figure. So again, just to reiterate, we have this figure object. In fact, I can say what the type of fig is, and it reports back that it's this Matplotlib figure object. And I can add as many set of axes as I want, and then I can plot on each of those axes. And by default and by convention, since we typically only have one figure, we call this PLT figure just fig. But for the sets of axes, we like to label them because typically we're going to have more than one. So for example, I could say this is axis 1, and then plot on axis 1, and I run that, and I get the same results, as long as I am consistent in my notation here. So what we're going to do is we're going to have a large set of axes, and then I'm also going to have a small set of axes, just to get an idea of how we can add multiple axes. So let's go ahead and say axis 1 is this original add axes, basically the full size of that figure canvas, and then we'll say the following: axis 2 is equal to, grab that same figure, and they should all be going inside the same cell, and add another set of axes. And this is where you can really play around with the coordinates you provide to get an idea. So the main way I was able to understand the coordinate system and the width and height system was just playing around with these numbers and seeing the relationships. Let's go ahead and make a smaller insert plot or insert set of axes. So if I want it to be inside of this larger plot, that means I shouldn't be starting at the corner of 0, 0 for my canvas. Instead, I should be probably starting maybe 20% in on the x-axis. And then let's go ahead and start 20% in on the y-axis, and then we can move it around. So we'll say 0.2, comma 0.2. Again, this goes from 0 to 1 in relation to your actual figure canvas. If you go above that, say something like 2, that's okay. It'll just go kind of twice the length of x in the figure canvas area. But right now we'll just stick from 0 to 1. So we're going to say 20% in on x and 20% up on y. And then we have to decide the ratio of how big this new set of axes is going to be. Since I want it to be smaller, I'll go ahead and say the following: 0.5 and 0.5, which means the width should be half the width of the entire canvas, and the height is going to be half the height of the entire canvas. And so if I just run this right now, notice I'm actually not going to plot on axes 2. There we have this new set of axes. So note, it starts about 20% in and 20% up. And then we have a plot that is half the height and half the width of the other set of axes. And right now it's blank because it's just a set of axes. So let's go ahead and play around with this. Let's make it, instead of 0.5 by 0.5, 0.1 by 0.1. That means the width and height are 10% of the size. And note how much smaller it is. So essentially 10 of these little squares along the x and along the y axes would make up the entire plot size. Okay, so probably a happy medium would be something like a quarter of the size. So if we run that, we get a quarter of the size, and let's go ahead and move it up a bit. And if I want to move it up, that means I have to deal with this second parameter, which is the height, or the up on the y-axis parameter. So essentially, how much off of the x-axis are we going to go? So let's go ahead and shift it up to 0.5, which means it's going to start the bottom left-hand corner halfway up the canvas. So again, I highly encourage you to play around with these values to make sure you fully understand what each of these 4 values represents. You have the x and y coordinates of the bottom left-hand corner, and then the width and the height of the axis itself. So you could always expand on this. For instance, make one of these 0.5 if you wanted to just make it taller or wider. So let's go ahead and set this so that it's square at 0.25, 0.25. And that means I can then grab that second set of axes and I can plot on it. So I could say maybe plot x and y on this. And now we have these 2 separate plots, x and y, and then a and b. Now in real life, this probably isn't super useful to have an insert which is a completely different plot. However, it is quite common in real life to have a zoomed in section on your plot as an insert. So let's go ahead and start learning how we can add specific labels and titles to each set of axes individually. So the way we're going to do this is it's going to look really similar to what we learned about in the Matplotlib functional method calls. The main difference here is that when we're adding it to a set of axes, we say .set underscore on these. So let's start by dealing with the large axes. I want to add in a title and an x and y label. So we'll say axes 1 dot, and then we say set underscore, and then what we're going to do here is say things like set the x limit, axes 1, set the y limit, and then we can also say, whoops, this should say axes 1, there we go. Axes 1, also we could say set underscore x label, axis 1 set underscore y label, and then we can even set a title, axis 1 set title. And this commands should all look very familiar to you because they're pretty much the exact same commands that we learned about in the Matplotlib's basics section. That lecture, remember we said PLT, xlim, ylim, xlabel. So the only difference is when you're calling it on a set of axes, you just say .set underscore, and it's the same set of commands, xlim, ylim, etc. So let's give these x limits. Let's go ahead and say from 0 to 8 for this larger plot. We'll set y limit to go, let's say if we're going 0 to 8 here, maybe 0 to 8,000. So we'll say 0 to 8,000. And then x label, we'll just call this A. Y label, we'll say B. And title will be something like power of 4. So when we run that, we see that I can add individual labels and titles as well as set limits to this set of axes while not affecting the inner set of axes. But I did mention, typically on these inserts, you're zoomed in on a particular portion of the plot. So let's go ahead and now start editing axis 2. And a nice way to do this is to simply copy all the commands we just did for axis 1 and then paste it below here on small axes and then just change all of these to say axes is 2. So I'm just going to come down here and change these all. So now I'm dealing with axes 2, and let's have this be an insert. So I'm going to say the title is zoomed in, and then we'll just zoom in on, let's go ahead and zoom in on from 1 to 2. So we'll say the x limit on this insert is 1 to 2, and now instead of plotting x and y on the second set of axes, I'll have it match the original AB. So all I'm doing here is I'm essentially doing a large plot of A and B and then doing a small plot of A and B. Same information, but one of these is going to be super zoomed in. So instead of showing it from 0 to 8, I'm only going to show it from 1 to 2. And then if I'm only showing it from 1 to 2, then my y limit should probably be a lot shorter, maybe even something like 500. So let's make that, let's say 500. We'll have this still be AB and then zoomed in. Let's see if that makes sense. We run this. And it looks like our y limit is still a little too short. So let's go ahead and make it 100. And even then it's still too short. Probably make it 50. It is just to the power of 4 after all. So that'd be 2 times 2 times 2 times 2. And then we can see a zoomed in portion here. So here we can see two sets of axes all in the same figure. And then we can plot whatever we want on both of them. And that's the main idea here. You can add as many axes to the figure as you want. And technically, you can place them wherever you want. So just to show you how flexible this figure object is, I can actually change this figure axis to be the corner at 1, 1. So if we think about where the corner at 1, 1 means, it means go all the way to this top right-hand corner of the blank figure canvas and then start the set of axes there. So when I run this, I should see this zoomed in square actually start here at the top right corner because I changed this to 1, 1. And when you run that, you do see that as the result. So hopefully that helps also if you're understanding of the set of axes and what you can do with them. You can also actually make these larger than 1, 1. So for example, I could make this 2 by 2, which essentially means make it double the size of the blank canvas underneath. So if you run that, now you get this huge zoomed in picture. So hopefully that helps your understanding of what these coordinates are actually doing, as well as the fact that you're technically not limited to 0 to 1. And a lot of times people experiment with things that are outside the initial figure because maybe they want to post something like a legend outside of their plot. All right, main idea for this lecture though is we create a figure, add a set of axes to it, plot on that set of axes, and then set and adjust your parameters, including x and y limits, x and y labels, as well as the title. Okay, coming up next, we'll talk about figure parameters and exporting a figure. I'll see you there.